Welcome back to the Rad Lab Podcast. This is part of our interview series where we interview a professor or a leader in their field so we can learn more about their research and learn hopefully a little bit about them so that we can get a better idea of how they got there and where they're headed. Hopefully this is going to be a good resource for them as well as for any students out there, any prospective students out there that may want to join their group. So today we have Dr. Kyle Murphy here at Tennessee Tech University. And I guess firstly, just tell us about a little about where you came from.
Sure, yeah. So I think anyone can relate, but we are very much a culmination of our experiences. And so my research and what I do in my research group is really reflective of that. So when I was an undergrad, I did research I went to Bridgewater State University up in Massachusetts. And the research I did there was primarily green chemistry research / organic chemistry research, where we investigated ways to make certain chemical reactions less hazardous. Is sort of the key focus of green chemistry, is doing things in a safer way, a more sustainable way, et cetera, et cetera. And so from there, I went to the University of Vermont, where I did polymer chemistry research with, again, an organic chemistry focus. And that was a big shift for me because I wasn't really sure what I wanted to do for my research when I went to grad school. And that's like tough too, to you might have an idea of what you want to do when you get to grad school. The people who are accepting you or accepting research students in the groups may not be doing the kind of research you thought you wanted to do initially, or it's so different from your undergrad that you're not really sure in the long run what this is going to look like. Luckily, I fell into a group that matched my interests, I'll say, where when I was an undergrad, the chemistry I was doing was small molecule stuff. In grad school, I was doing polymer chemistry, so big molecules, which was so different and so interesting just from a I don't know, like a visual, a mental standpoint, because I wasn't just making these small molecules, I was making these big molecules, right, macromolecules, polymers, and I was making these shapes, essentially. I was making these helical springs, which was just so interesting that you can do that kind of thing with chemistry. I felt more like a chemical architect than a synthetic chemist. Right. I think having something that you find interesting, even if it's just for the childish reason of I like to make shapes with my chemistry, I think if you can find something that interests you in grad school, that's really what you should pursue. And so from there, I went to UNC Asheville, which is a small liberal arts college, for my postdoc, which was a research and teaching postdoc. So I was doing research with Dr. Amanda Wolf there, and I was helping mentor the undergrad student she had doing research. And that was a very medicinal chemistry research project where we were looking at making new antibiotics and finding ways to make current antibiotics more effective. And so the research I do now is very much that culmination of green chemistry, polymer chemistry, and medicinal chemistry, all umbrellaed under organic chemistry.
Yeah, no, I definitely agree with how you were interested in the springs and the shapes and things like that, because for me it was colors that got me, colors and crystals, like going from a organic heavy lab and then switching over to a more inorganic actinide lab, and those colors and crystals, they just seemed a little bit more attractive to me than just looking at white powders all day and rotovapping everything. Okay, so you said that it seems like you have a lot of background in a lot of different things. How are you combining that into your research now?
Mm-hmm. Yeah, so my research projects generally have, again, in that general terms, have one or more links to green chemistry, polymer / macromolecule chemistry, and medicinal chemistry. Two of the big projects I have going on right now with the research students I have in my lab, one of them is making these porphyrin-like macrocycles. Again, shapes, in this case 2D planar rings, in the hopes to break down nanoplastics. I think a lot of people know what microplastics are, and I don't think I need to tell anyone the issues we're facing right now as a whole with plastics in the environment, especially in our water systems. Like the Great Pacific Garbage Patch, for example, is one big, I think, a very visual issue. So there's these things called microplastics, and they're small, like table salt sized bits of plastic. If you go one level deeper, you have nanoplastics, and that's been an issue that's only been really known about the past few years. And primarily, people have been looking at polystyrene for these nanoplastic investigations. Polystyrene can be found in things like red Solo cups, styrofoam. There's more examples, but those are the two most prevalent ones. And so what we hope to do in capturing these nanoplastics is prevent them from doing further damage to the aquatic systems they're in, because nanoplastics are the size of cells, essentially. And these polystyrene threads are hydrophobic, so they will bundle together because they don't like being in water. But when they get into a cell, they can fit into the cell pretty easily. They will begin to untangle. And so these individual polystyrene threads that go into cells will end up killing them, which is, of course, bad for aquatic life. So what we're hoping to do here is with these macrocycles that we're making, which have electronic and structural properties similar to polystyrene, we're hoping that the polystyrene nanoplastic bundles will sort of fit into the cavity of these macrocycles and untangle them before they can do any damage to the water systems. So we're hoping to make something of a silica gel type column with this macrocyclic material, and then see if we can push it through and untangle the polystyrene nanoplastics before it can do any damage to the water systems, and see what we can do to individually untangle those threads. And similar to that, so that was sort of an example of polymer chemistry and green chemistry combined. Another example that we're looking at for research is looking at furfural as a source for antimicrobial materials. So furfural is this compound that can be made from general biomass, so things like corn husks, sunflowers, that sort of a thing. And it's known as a platform chemical. So furfural can be used to make a lot of different things because of its renewable feedstock ability. Instead of getting things from petroleum, if we get it from renewable biomass, that's great, because we're going to run out of petroleum sources eventually. So what we're looking at here is furfural derivatives as a source to combat antibiotic problems that are happening right now. So currently, there's sort of a discovery void in antibiotic discovery. So we're not finding any new antibiotics, at least not at the rate we were initially back in the earlier or the mid-1900s. And bacteria are becoming more and more resistant generally to the antibiotics that we do have. So a lot of the research going on now in that field is trying to find ways to make either new antibiotics, make them more effective, or make bacteria less able to deal with antibiotics. And so one thing we're looking at is finding a way to combat something called biofilms. So if you have a lot of bacteria on a surface, they'll do something called quorum sensing, which allows them to sort of bundle together to make a biofilm, which is as gross as it sounds. And that's a big issue in hospitals, where you'll go to a hospital to get treated for something, or surgery or whatever, and you'll leave with an infection. Because these biofilms, it's harder to kill all the bacteria. It's almost like they have like a surface or a shield around them, where you bleach the surface, but you don't kill everything because there's just so much there. So what we're looking at is this certain functionality, acyl hydrozones, which are known to disrupt this quorum sensing going on. It won't kill the bacteria, but it'll stop them from making the biofilm, which is important. So we're trying to look at furfural and make this certain functionality and make materials out of them. So taking furfural and almost polymerizing it and have a consistent source of this functionality and see what that does to prevent biofilm formation. So that's, I guess, a combination of all three: green chemistry, medicinal chemistry, and then also polymer chemistry.
Yeah, no, that's great. So going back to the nanoplastics, didn't they recently discover like nanoplastics in like humans now?
Oh, sure. I mean, I think that might have been microplastics, I forget. But regardless, there is evidence of plastic in the tallest mountain in the world and in embryos. Like, it's just everywhere. It's so pervasive. And so and the reason why nanoplastic exists, right? Again, microplastics, table salt, nanoplastics, cell-sized, they just break down. It's almost like erosion. So eventually we're going to have more and more nanoplastics, and to become a bigger and bigger issue. Yeah.
You don't want to be drinking any of that stuff, right?
Right, yeah.
So any way to mitigate that kind of like expression into the environment would make a great difference, right? So for bacteria, I haven't looked into a lot of this, but I just remember like in some class I took, some biochemistry class, they found that if they go back to older antibiotics, that they don't have the same resistance, right? Their coding can't keep that memory all the way back from when they were starting to gain resistance from older antibacterial drugs, let's say. So are they starting to hold on to that memory a little bit longer, or are we just not going back to that? We're not trying the older antibiotics anymore.
That I know less about. I was not aware of that particular issue. It does make sense, but I imagine if that was, for example, the issue, if we did go back and use those earlier antibiotics, I imagine we would face the same issue where they would become probably quickly resistant. So it's like, that's why if you get antibiotics from your doctor, you want to make sure you take the whole dose. Because if you stop halfway through and all the bacteria have not been killed, you're leaving the ones that were not susceptible to the antibiotic, and you're allowing them to grow and make more of themselves, right? And so those are going to be more resistant to the antibiotic.
Yeah, and that's been the biggest issue, right? People just not doing their complete run of antibiotics.
Well, that, and also with COVID happening, antibiotics have been lent out even more readily, especially with this last year with all the viral infections that have been going on. But this past fall of 2022, everyone was getting the flu, and so antibiotics were also being given out more readily. That's just going to lead to more issues, because the more people are getting antibiotics, like you said, maybe some of them are completing their dose, whatever, but the more we lend out antibiotics and the more freely we do that, the more issues we're going to have.
Yeah.
Because bacteria are always going to find a way to gain resistance. And we can't, despite what some YouTube videos show, you can't drink bleach to get rid of your viral infections.
Yeah.
So
with these furfurols that you're trying to make, and trying to make them into almost like plastics and things like that, do you see them being kind of shaped into like scalpels or different things for actual like medical like procedures? So then you don't have to worry about because I'm sure that's probably where some of that infection comes from.
Yeah, that would be incredibly interesting for sure. Some of that antimicrobial surfaces do already exist. You might have already seen, if you go to like a airport or a hotel, you'll see descriptions of what the buttons are like. So for example, I'll focus on the hotel. If you go to a hotel and there's buttons, you can see it says antimicrobial surface, or it says self-cleaning surface. What that means is that surface, when you touch it, there's something on that surface, whether it could be copper ions, something of that nature, will kill the bacteria as it lands on the surface. So that kind of thing already exists, but it's not as ready for commercial use, and certainly not, I think, for medicinal use, because I think we just don't know what that could do. Because the last thing you want to do is introduce something into someone's body that could kill bacteria, because not all bacteria is bad bacteria, right? We're learning more about the gut biome and how important that is. So we don't want to introduce something that'll totally kill out things like your gut biome, or even like the bacteria in your mouth. That's why you don't really want to use mouthwash too much, because you'll get more sick, because you're getting rid of all the good bacteria in your mouth.
Gotcha.
Yeah.
But like something like a doorknob or something like that, something high,
right.
a high touch surface, right? Something like that.
Right. And the beauty of using furfural too is, again, it's a renewable resource. So the more things we can make out of this renewable resource into something like polymers or plastics, the better off we're going to be, right? Because even though, like I was saying before with polystyrene, the end of life for things like styrofoam and red Solo cups is just a very long decomposition process that just is going to take a really long time, which is why we get things like microplastics, nanoplastics. So if we can do this sort of two-prong approach of let's make these plastics or polymers from a renewable feedstock source and then find a way to get rid of them in a way that is sustainable, that's the ultimate goal, right? So that we don't have to worry about these polymers at the end of their life, and we don't need to worry about where we're getting it from.
So are furfurols, are they easier to break down after they've been used for like recycling or things like that?
I mean, they are very small molecules, and so furfurol has a good track record of breakdown already, and it would be easier to get it back down to its sort of like root elements, if you will, CO2. But I mean, I think we still have a long way to go in terms of figuring out what we can really do. Because an issue too is one of the only really good examples of a polymer that has a great end of life is polylactic acid. which is something commonly used in 3D printing. It's getting used more for commercial plastics, but it's not the toughest material around. And that's the issue, right? If you're losing the structure of the plastic, the polymer, when you try to make it more decomposable. We're going to find a way around that eventually, but it's hard to, if you make something that's structurally weak, it'll break down easier, but you can't use it for much, right? If you had a plastic that dissolved in water, you would think that's great, but you can't get it wet at all, right? Which is a hard thing to do when you have car surfaces that are made out of polymers. You have plastic bags that are made out of polymers. If those get wet and break down, that's a very useless commercial item. So it's hard to find that balance of, is it structurally sound and can we break it down at the end of its life?
Well, I'm sure you'll be able to figure it out.
No, we'll see. I'm optimistic that eventually we will get there. We'll find a solution to it that makes sense. We don't have to keep polluting our earth with these plastics that we're just either putting in a landfill or it's ending up in the water.
Yeah. So let's take a few steps back here. So we've both been through a lot of school, right? And I think the biggest hurdle was probably grad school. So what kind of advice do you have for someone who's maybe on the fence about going to grad school or, maybe going into industry right away? What is the argument for going to grad school? And then I'll ask you, what's the argument for going to industry? So let's start off with going to grad school. What's the argument you have?
I'll say this before we get too far into it. I don't know a ton about industry, which will tie into grad school here in a second, because I was not really given that sort of an option. There has been, I think we're shying away from it now, but there's not a lot of, in my experience, support for students in grad school who want to go to industry. They're kind of left to their own devices to figuring out that, like, if you're in grad school towards the end, you're getting a PhD, you're doing all these interviews to go to find a job, you may not be given the best support to get an industrial job, in my experience. However, I will say this, if you were thinking about one or the other, there is nothing wrong with kind of almost like testing the waters, right? If you go to industry and it's not for you, or if you wanted something more, you can go to grad school. And people do that quite a bit. They'll go to industry for a year or two, decide maybe it's not for them, or then go to grad school. Or vice versa, right? If you're not happy with where you are in grad school or what you're doing, there's nothing wrong with saying, okay, like, I am finished here. Like, I want to go pursue something else. So that's, I guess, my general advice there. But in terms of, like, if when you are in grad school and going through that process, I think especially early on, I think a lot of people would agree with this. And I said this before, if you find the chemistry interesting, that's great, right? If you are joining a research group and you really like what they're doing, awesome. However, if you are in a group that is very toxic, whether the PI is toxic, whether your group mates are toxic, and there's a lot of ways to be toxic, and I won't go through all that here, but if you find that you are not happy in that group, and you can see it early on, finding a group that you're happy with versus a group that you find the chemistry interesting in, that's a debate for you to decide, but I would argue it's better to be in a group where the PI is supportive of you, and you find your mental state will be happier there, which is, it's hard to know that ahead of time. That, I think, is the group that you should go with, because you can always learn new things later on. Like, I'm a polymer chemist, but I had to learn a lot of the polymer chemistry I learn now when I started my job, right? You can always pick up new skills. That's kind of what the PhD does for you. You get a degree in advanced problem solving. You can pick up the skills. Those will come. But being happy and having a supportive PI, that's going to be way more beneficial, because that supportive PI may support you beyond your degree, right? So having that sort of resource available to you for the rest of your career is going to be super valuable as well. So that is my general advice for grad school, is find a group that you think you'll be the most happy with. If the chemistry is interesting too, great. But I would argue it's more beneficial for your career, your mental state, to be with a group that you find you'll be happy with.
Okay, so let's say I've decided I want to go to grad school, right? And I'm going on my visits. What's the best way to try to figure out this information before and inform yourself about what school you want to join and what group you want to join?
I think the easy way to do that, and I think if you ask anyone this advice, this will come out of their mouth to some degree, is ask the group mates or ask the group members what their opinion of the lab is. And in grad school, you'll get a range of, if they're a predominantly PhD granting institute, you'll have a range of first year grad students to fifth year grad students. Maybe there'll be postdocs in the lab. They'll probably give you maybe a range of advice, because grad school, no matter what you do, is going to be a little bit of a draining process, right? Especially if science doesn't work, you're having a rough time in the lab with research. It's going to be draining no matter what. But what you really want to ask is, how do you feel about the group? Do you feel like the PI is supporting you? Will they support your end goal? Will they support you whether you're going to industry, whether you want to do a postdoc, whether you want to go into teaching? Those are all important things to ask, because if the PI isn't supportive, you might not really want to join that group. And the group mates will probably be forthright with you, especially if they are a bit later in their graduate school career. They'll be, I think, a bit more forthright with that information.
Yeah, I always think it's the students that are on their way out that are always the most truthful.
Yeah, it's sort of like the canary in the mine situation, where if the canary dies in the mine, something bad's going on in there. The grad students will be that sort of a telltale sign of whether the group is happy or not. Or even like outside of, even maybe before you go to grads, that visit or after the visit, if you go to that group's webpage and you had maybe talked to one of the grad students, maybe they'll give you the email, maybe email them after the visit and be like, especially if you didn't get a great chance to talk to the grad students, you could ask them through email, like, what do you really think? Please, give me your honest opinion on this. And beyond the visit too, once you're actually in the program, you will probably have your choice of a couple different professors. You can ask the grad students then too. So that way, again, you have a good idea of what you may be getting yourself into.
So let's say you were going to start all over. Let's say put you in a time machine, but we only let you keep one skill to go through grad school again. What skill would you want to hold on to?
As an organic chemist, my first instinct is say running columns really well. Saved me a lot of time. But I think honestly a bigger skill is asking for help, asking for assistance, which is not something I did in grad school. My undergrad career was, again, I was at a liberal arts college, and it was a great time doing research, but I did not really gain, I think, the skills that my peers had when it came to doing organic synthesis. So I had a lot of catching up to do. And I was afraid to ask for help. So when I got to grad school, I didn't really know how to run a column super well. I didn't really know how to use SciFinder to look up reactions. I didn't really know how to plan my lab notebook out or my week out for reactions. I learned it all eventually, but I kind of learned it on my own or by kind of sneakily watching what the postdoc was doing, which is not really what you want to do, right? Because I was kind of embarrassed to ask for help. It's like, I should know this already. Like, what am I doing? Like, I'm overwhelmed. I'm teaching 3 different labs right now in my first year of grad school. And it just took me a bit longer, I think, to get to where I probably needed to be to start doing research really effectively. So if I had to pick one thing to take with me early, it would be to ask for help. Because I could have probably learned all that in my first week. How do I set up my notebook? Like, what do I do with this? And it would have been like, boom, boom, boom. Like, here's what you do this. If you need more help, ask me. Because that's the advice I usually got. When eventually we started learning how to ask for help, is they would be like, ask me more questions. Like, what else do you want to know? I'm happy to help you, right? And I try to say that to students now, because it's like, sometimes they, just like me, they're afraid to ask for help. And even as a professor, I'll ask for help if I don't know how to do something, because you're gonna waste your time trying to do it on your own. Sometimes it's good, right? Sometimes you just need to learn how to make mistakes too. But I think asking for help, is nothing wrong with that for sure.
Yeah, I think it's great advice. Yeah, definitely save yourself some time. Yeah. Don't be too prideful.
Yeah, exactly.
Just,
ask for help. Put your ego out of the way and just do it. Just ask for help. Ask multiple people for help. Ask the same question to multiple people. You might get different answers that'll help you even more. So when I'm preparing for a class for the first time, I'll ask multiple people, like, what did you do? What did your slides look like? What did your lecture plan look like? And I'll get a different advice, and I'll pick what I find more relevant to how I want to teach or how I want to do something.
Yeah, no, I think that's great advice. Yeah, I think I need to do more of that. Even now, I think most people should ask for help more often, and put the ego aside. And yeah, I think I think that's great advice for sure. Yeah, that is a skill. People don't think that's a skill, but asking for help is a skill.
Put it on your resume.
Yeah, exactly.
Actually, that might not be a bad thing to put on your resume.
Might not be.
Professional help asker. Because you'll know you're not afraid to ask questions, and that could be an important skill.
Mm-hmm. Okay, so let's venture outside of the lab now. You got to stay sane. So what do you do to keep you sane, or what do you like to do for hobbies and things like that?
I'll start at the beginning of grad school. My first hobby, quote unquote, was running. And I think exercise in general, no matter what you're doing, whether you're in grad school, whether you are out of grad school, whether you're done with school, exercise is a really good way to sort of keep you grounded in a way. The amount of times I've had a bad day in grad school, gone home, went for a run, and then felt better was 9 times out of 10 is what happened. Not saying it's going to be the fix-all to everything, but if you are exercising in some form, that's really going to keep you mentally healthy too, not just physically. And after that, I would say my second hobby, which I find more enjoyable because I'm not physically exerting myself and getting exhausted, is Dungeons and Dragons. And so, which is, I'm a chemist, probably the nerdiest thing I could say for a hobby. But that helped me more than I thought it would have. I tried playing in college and I was like, this is dumb. I don't like this. Because with D&D, Dungeons & Dragons, you need a group of friends. You can't just play with strangers or people you don't know because you're not going to gel well. It's like, I describe D&D as like you're around a campfire telling a story together. It's dynamic storytelling. But it's also sort of a public presentation skill. Because when you're playing D&D, you're playing a character, or if you are the dungeon master, you are sort of narrating the story. And I did a lot of being the dungeon master, the DM. I started doing that in grad school, and I remember so distinctly giving a really bad literature presentation. It was just bad. I knew it was bad while I was giving it. People afterwards said it was fine, but I was like, I can tell they didn't think I did a good job. And then I started DMing. And once you start pretending you're a dragon in front of your friends for 3 hours, you start becoming a bit more comfortable just presenting information. And there's a lot of improv that goes into it too. You're sort of thinking on your feet. You're playing different roles. Your mind's kind of going in between different story beats and narrative points. And then I gave a presentation 6 months afterwards, and it was the best presentation I'd ever given, ever. And I was kind of realizing, me playing D&D is really helping me in present and also to teach. So I would say it is very much a hobby, don't get me wrong, but it has been very helpful for my public speaking for sure. And just my ability to teach and sort of think on my feet and kind of be able to navigate between different mental states while I'm teaching.
Oh, I think that's a great way to use Dungeons and Dragons to definitely help you on multiple levels. Yeah. One way I got around, I guess, my fear of presenting and things like that is I took an acting class.
Oh, yeah. I mean, same. D&D is just theater.
Yeah.
That's all. At its heart, again, if you're playing with a group of friends who really want to delve into the social aspect of the game, it's just theater. It's just acting, really. So I can definitely see how that would help for sure.
Do you think the fear ever goes away if you're afraid to present? If you're afraid of public speaking? Because I think for me, I don't think the fear ever goes away. I think you just learn how to control it better.
Yeah, that's one thing too. Again, I've only been teaching at least lectures for a few years now, and it's always a little bit nerve-wracking before you start teaching. Even if it's halfway through the semester, there's always a little bit of that anxiety of teaching. What I will say though is what kind of pushes me through is I know that when I start teaching, that kind of goes away a bit. The moment I start lecturing, it's just fine, right? No matter if it's 100 people, 10 people, 30 people, it just goes away. And I think that comes with practice, but the fear, I don't know if that really ever goes away. You just kind of learn how to deal with it a little bit better, or know that, okay, I know when I start teaching, it's going to go away, so I just kind of have to sit with it and be okay with it, which is hard, right? That's also a skill to kind of develop, but it does get easier. And the thing to kind of know too is that generally when you're presenting, the audience doesn't really care. You could fumble over your words or something, and I don't ever remember a professor fumbling over their words, ever. They probably did a bunch. I just don't remember. I was either like confused with what they were talking about, I was zoning out, or whatever, right? So keeping your audience's attention is a different story, but generally the audience does not care about if you fumble over a word or two, or if you have to stop and be like, I don't know the answer to that question you just asked. We'll circle back to it. Things like that is, again, it's a skill, but in general, the audience doesn't care too much about your teaching style or your public presentation style, which is also something to keep in your head while you are teaching.
Most people are more worried about themselves. And the anticipation is always worse than the actual act, I guess, of like presenting in front of someone. But yeah, I think it's definitely a skill to try to control that kind of anxiety and that anxiousness, right?
Yeah.
Okay, so let's end it off with a more worldly question here. Okay. What is the key to happiness?
I would say, and I bet if you ask a lot of people this, you'll probably get a similar answer. You could say things like exercising, eating well, having a nice family, having friends, things like that. But I think you kind of have to find what happiness means to you. And I would almost say, if you don't mind, I'll make the question, what's the meaning to life? Which is maybe a little bit easier to answer. Because I think the meaning of life is kind of whatever you want it to be, right? There's no rule book for how to live your life, right? There's no rule book for how to have happiness. You have to find what makes you happy, which is hard, right? I'm 30. I don't really know if I've necessarily figured it out. I'm trying to. But it's about kind of trying things that work and see what doesn't, see what sticks. Maybe having a lot of friends makes you happy. Maybe having a couple of friends makes you happy. Maybe exercising does, maybe it doesn't. So it's sort of about trying things and seeing really what sticks. So I think the key to happiness is really about just doing your best to find what that is. Because I think there's no real clear, great answer for that. But what I will say is, I think happiness is sort of what you make of it. You can always be thinking about, like, when I finish my PhD, I'm going to be happy. When I get this job, I'm going to be happy. But there's just more life after that. You're going to be there, and then it's just, what's the next thing, right? So I think it's kind of about finding happiness wherever you are in that pocket of time, whether it's a year, 5 years, the rest of your life at some point. But it's about finding that happiness in that pocket of time, right? Finding happiness where you are versus where you're going. Because you may get there and be like, I'm not really happy with this, right? Or I don't know, this is not what I thought it was going to be. So yeah, I think just finding it where you are, that happiness is what the key to that is.
Appreciate what you have.
Mm-hmm. Sure, I mean that too. Yeah. I mean, something said about gratitude, but I think just being open to it and kind of, don't lose hope in searching for that. Yeah.
Okay, well, thank you for being on here. Hopefully you enjoyed it. I definitely did.
Well, thank you for having me.
Yeah, I learned a lot about you and a lot about your research, and I can't wait to see what you do in these next, hopefully these next decades coming on.
Me too.
And hopefully we'll be on this ride together. All right, well, thank you for listening, and we will see you on the next one.